Alright, now we're going to put all these transformations together and see if we can understand what's going on here. If you're given a parent function, f of x, okay, and transformations of f, which could be all kinds of stuff here. Here we have, if g of x was a function multiplied by a constant, here we have x plus or minus h, and then we added or subtracted k from it. We have all these different transformations that we've talked about. The graph of g of x can be obtained by following the sequence of formations. We need to first look at our horizontal shifts. Secondly, we need to then consider our reflections. Okay. Third, our stretch / compression, right? And lastly, consider our vertical shifts. Okay, so let's take a look at this. Describe how you would graph g of x, which is x plus 2 quantity cubed minus 5, using transformations of the parent function. Well, first, I would say, the parent in this case is f of x equals x cubed. Okay, 2. I have a horizontal shift here, and a vertical shift. Horizontal shift, vertical shift. Okay, so according to what we talked about up there, we would shift the function. We would shift f of x first 2 units left, because it's plus 2. 3, you would shift, then again 5 units down. Okay, and that would achieve our graph. Now the next one's a little trickier, okay, because it has something else. Alright, let's look at this. Describe how you graph the function here. F of x equals 2 times the absolute value of 3 minus x plus 2, using transformations of the parent. First off, we need to realize, 1, that our parent in this case is y equals the absolute value of x. 2, before we do that, maybe we should look. Here we have a compression / stretch. In this case, it's a stretch. Okay, so we identify that. Then we have a horizontal shift. We also have, in this case, since x is negative, a reflection over the y-axis. And then we have also a vertical shift. Okay, so we got a lot of things going on here. So if we follow the chart above, we want to first shift y equals absolute value of x 3 units to the left. Why is it to the left? Some of you are probably looking at that minus, because the 3 is actually positive. So we'd shift that to the left. Then we would reflect over the y-axis, okay, because that's our reflection. 4, we would stretch, right, vertically, by a factor of 2. According to the steps. And then lastly here, we would shift that graph up to land on the graph that we want to achieve there. Alright? And that's it for 2.6.